A very good morning. Assalamu alaikum to everyone. First of all, I would like to thank Mr. Ibrahim Lari, the team of SIPCA, to really give us this honor to come and speak on the stage on the specific technology of Siemens ASA technologies. Now, myself, I'm Syed Akbar. I am heading the fire business here in the UAE and the Oman market. Today's topic is very specific on the very basic of the fire detection. And why we choose this topic? Because of one specific reason. And that reason is, it's on the screen. False alarms are one of the key pain points that we see across the industry. And how can we overcome these false alarm scenarios? Because as the colleague, Mr. Mike from NFPA, he rightly mentioned that the environments are changing, the challenges are different, and we need to encounter them together. And this is exactly what and how we could achieve. But at first, is this the right answer? Deactivating the smoke detectors and trying to escape from the false alarm? Unfortunately, no. That is not the right answer. And we worked on a specific technology which we call as Advanced Signal Analysis smoke detectors. And these advanced smoke signal analysis detectors come with a very unique capabilities. Now, these capabilities are specifically within the detector by itself. As you see the picture in the center, it is the chamber of a smoke detector. And in this detector chamber, it comes with a dual optical sensor, it comes with dual thermal sensor, and an optional of a carbon monoxide sensor. Because we all know that if there is a true fire, there has to be smoke element, there has to be a heat element, as well as there has to be a certain amount of carbon monoxide element. A combination of this altogether can prove that the fire is a true or a false fire. And this is the only UL listed detector which has got forward and backward scattering detections. Now, I go a bit more deeper into this topic for us to explain and understand how this technology precisely works. The detector by itself has got multi-sensors. It has got optical, it has got thermal, it has got a carbon monoxide. And with this signal evaluation, what it does is, it also looks into the environmental factors, because the detectors that we put or install sits in different environments. Now, for example, a room of this nature, is it same to the room of an electrical room, or the lobby, or the lift areas? No, every environment has got a different challenges. And these challenges, these environmental factors are something that we need to take into consideration while we ensure that the detectors is acting upon a certain results. So this is one key factor that we take into consideration of these detectors. The next factors is, it has got an inbuilt smartness. Now, when I tell inbuilt smartness, what does it really mean? The inbuilt smartness is every smoke that burns, every material that burns, like for example, silk, wood, PU, has got a specific characteristics has got a specific smoke characteristic. And these characteristics has been recorded in our laboratories, and we have stored more than 5,000 smoke signatures onto every detector, which means that it understands whether this smoke which is coming to the detector, is it a smoke coming from a specific material that is being burnt, or it is a smoke coming from an deception, which is not a real smoke. So that is the intelligence that we have given to this detector. And with all these given factors of the smoke signatures, the environmental compensations, and the multi-sensing capability which it has, it does something called as a real-time interpretation. And finally, we come to a conclusion that yes, whether this is a true alarm or a false alarm. Now, there might be a thought, Like, okay, if this detector does so much of things, maybe it's very slow, it's not very sensitive. No, that's not the case. Here, this detector is listed as a very early warning fire detector. So it acts quite fast. At the same time, it acts very smartly towards the false scenarios. So given a scenario where we have this detector with all this smartness and the real-time situations, so we have several deceptions across our environment. Deceptions could be like smoke, exhaust gases, welding, steam, dust, electromagnetic interferences, fibers. So all these substances create a deception to smoke and creates false alarms. But whereas a true fire has also a certain significances. So we map both these scenarios and then try to make a decision which is a true or a false. And we are so proud of this technology that we have been using this technology in multiple facilities across the globe, in Europe, in America, and across the Asia Pacific, Middle East countries. And we guarantee that with this detector, again, with properly installed design as per the NFPA, we cannot have a false alarm. And if there's a false alarm, specifically in countries like US and in Europe, there are penalties that are countered to the end users. So these penalties we take on our shoulders, and we are so confident on this technology. Now, I have a video which we conducted a couple of months back in our laboratory, and I would like to play this video. But again, before I get onto the video, I just want you to understand on this video. So you see two pictures, or these are two videos that will be played, and on the bottom is the source of fire, and on the top is the roof where we mount different detectors. And on the extreme right, you see the different type of detectors that we installed. So we had a regular smoke detectors, we had the specific ASA technology detectors. So the red color that is indicated on this graph is a regular smoke detector, which is a single optical sensor, and then the yellow, the green, the blue, purple, and the gray are all the ASA technology detectors. Now here on this, we have both in wired and wireless systems. So I would just like to play the video, and also on the top you see a graph which shows the obscuration rate of the smoke which captured during this test that we conducted. So let's play the video. So this is a specifically Bahur content which we used in this particular experiment. And then, because this is one of the challenges here in this part of the world where in residences there's a lot of Bahur that is being burned. And now you see that the amount of Bahur, that is the smoke that is being given out, and the detector, the first detector, which was the standard optical sensor, it jumped into alarm around less than 2 minutes. But the ASA technology detector picked up a specific signal of pre-warning and warning, but it did not trigger an alarm because it understood that this cannot be a true fire because it doesn't give the element of heat, it doesn't give the element of the required carbon monoxide, and the environment is different, which it cannot have such a scenario. So with this, we had several different tests conducted with the civil defense also in their facilities, trying to see how we can combat these false alarm scenarios. Now, the question is this a very special detector for a very special application? But the answer is no. It is a common detector that can be used in different environments. It's the same detector that are being used in data centers, archives, museums, hospitals, IT, and telecom equipment. As per NFPA 72, there is a specific clause that in the IT rooms and telecom rooms, there has to be a very early warning detection. So this detector complies to that very early warning detection requirements. And also the same detector can be utilized in moderate environments like hotel rooms, shopping centers, schools, airports, etc., as well as in harsh environments such as industrial production facilities, car workshops, hotel rooms with showers, for example, because they create a lot of steam and false alarm scenarios. Now, we have been using this technology, this detector in this part of the region, specifically in data centers, in many of the utility substations, for example. We have also been using this in the residences and also in the hospitality industry. So with that, the last slide over here is also talking about the range of detectors, which goes the highest range. What we have is ASA technology, but we have 22 plus profiles that can be selected for different applications. So with that, I would like to end my presentations, and thank you very much.